Hey, 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 it is time for Astronomy Daily Live. Hey, everybody, it is 2 hours UTC, and you can call me Cosmic. And hey, 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 hope everybody's doing well out there. I still have the sun shining on my face. The sun is just starting to set right now, just starting to go below the horizon right now. And before I forget, I'm going to come over here and tweet the fact that I am live. Yay. There we go. Cool. And I'm going to come over here and hit my smartphone and see that I'm live there. Yes. Yes, I think I accomplished everything. Okay, I'll see you tomorrow. All right. Well, I hope everybody's doing well. Come on in. Come on in. Join the circle of friends. We have wild kitties tonight in here. Um, he'll probably want out soon, so I will be summoned. I will be summoned. And you know what? For the second day in a row, I I do not have anything to drink. So I think I'll be all right. But if not, you will just have to excuse me for a couple of minutes while I do that. A new batch of hydrogen hydroxide is being prepared as I speak. So yeah, you never know if I'm going to have to dive into that new batch or not. So yeah, come on in, friends. Gather around the circle, um, or we can call it like a virtual porch, and we can pull up our little lounge chairs. Hey there, Bobby. Nice to see you in the chat again. You've been coming in pretty regular, so that's very awesome. Greatly appreciated. And yeah, so um, there have been a couple of things, and eh, yeah, I think this was really the only thing. Remember, a couple of days ago, uh, we took it a little bit easy and just sort of looked at some images from the moon. One of the things that I wanted to mention was a pretty good book um, that I I read for um, probably the first time, probably mm, close to 30 years ago or so now, and I've read it a few times since. But I definitely recommend um, this book. It's an Arthur C. Clarke book called The Fall of Moon Dust. And if you haven't read this yet, it's it, it's definitely one of Clark's better ones. Now, most of his stuff is okay. The one thing that I noticed about Arthur C. Clarke is is that um, you know it'll go on. The story will go on, and of course, it's really well written, and the characters and the plot and everything else is really cool. But it'll sort of go on and on and on and on and on, right? On and on, and you know, you keep reading, and it's like, when is this going to resolve itself? Now, we know that it's going to resolve itself by the end of the book, right? Supposedly, right? That's sort of the idea, right? So I'm talking about a fall of moon dust. Whenever I think of the moon, I think of this story. Um, but you're reading along. It's like, oh man, there's like, and I might be exaggerating a little bit, but there's the 10 pages left, and it's not finished yet, right? I mean, it's like they're right in the middle of this, right? And then and as I said, I'm sort of exaggerating a little bit, but It's like the last 2 pages. It's like problem solved, we're done, bye. And a lot of his books are like that. And I don't know if that's a style, um, if it's done on purpose, or if it's a thing where it's like, you know, has he gotten tired of it? And it's like, okay, I'm going to wrap this up, done. You know, not exactly sure, but many of his books do that. And this is the only spoiler I'm going to give, is that as I recall, at least this book does exactly um, the same thing. But really, really good book. And I think, if something like this would actually happen, I think, for those of you who are sort of concerned about being scientifically valid, and those kinds of things, yeah, I think it would probably happen about like that. Okay, I am being summoned. I must I must submit to the feline overlords and open this door, because see, the problem with being a cat, uh, one of the few problems that cats actually have is that they don't have one of these. So you know they know they know where the doorknob is, right? They know where the doorknob is. They know what it does, right? Um, and they try. In fact, I've seen some cats do it, but they try. But see, without one of those, they can't they can't grab things really well. So they must rely on their servants to open doors, um, for them, and open up, like bags and cans of food, those kinds of things. Those require thumbs that they don't have. So I'll be right back in like 10 seconds. Hold on. Okay, he was overjoyed. He was overjoyed, and you know when when the kitties are happy, everyone's happy. So yeah. Anyway, really, really great book. The other thing that when we were looking at the moon the other day, um, the Police song, "Walking on the Moon," sprung into my head, and um, I gotta say, I gotta say that it has been in my head ever since. In fact, yesterday, um, I got onto my keyboard, and I was playing it. I was playing it, and I actually made a recording, um, that I I was going to do like a little mix. I was going to do some vocals, all of that, and I recorded um, sort of the first part um, t- twice, and both times I didn't go long enough on the choruses. So uh, um, so after the second time, I was like, okay, I've had a, I sort of have had enough of this for now, for now. Um, but yeah, that song, at least for me, really gets into my head, and it sticks, and it sticks hard. It sticks hard, and it sticks long, and yeah, it doesn't want to go you know, I catch myself uh, um, um, singing along in my head, even now, right? Dun 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 dun. Dun. Anyway, and you know, I don't think that I'd ever seen the actual video of that song until pretty recently, and it's great. It's great. I mean, Stuart Copeland uh, is using the Saturn V um, uh, nozzles as a drum, right? You know, he's beating on the nozzles with his drumsticks and yeah, I mean, great. I mean, that song, um, if you look at the lyrics, have absolutely nothing to do with the moon whatsoever, right? It's the feeling that you have when um, you're you know um, uh, um, basically in love, right? And it's that feeling of just feeling very very light and uh, and so it's very appropriate, right? Because on on the moon, I think you're about one sixth of your weight here on Earth. So walking on the moon, you would be, you would feel very very light, right? And if you watch the astronauts that walked on the moon, they they weren't actually able to walk because of their suits. They could hop, right? They could basically hop, and so that's what you see them doing is sort of hopping around, and and uh, and so looking at the lyrics, at least that feeling, right, of sort of floating, being very very light um, on your feet, having spent the day with the person that you want to be with, and you know um, dropping them off um, at their house and walking home. It's a very very light feeling, and it's actually a feeling that I can relate to uh, because I've had that kind of experience. So yeah, I know exactly what those lyrics are talking about, and they're extremely accurate, extremely accurate. So yeah, cheers to walking on the moon. So let's see, there were a couple of interesting things. The one thing and I'm pretty sure, well, in fact, I know for a fact that you can go back and watch this. The SLU telescope network, well, maybe a couple hours ago or so, um, made some live observations of um, asteroid that is about a day away from its closest pass to Earth. Um, Apparently, um, it's going to be at its closest about half of the distance between the Earth and the Moon. And I think they said that was going to be happening around 22 hours UTC or so tomorrow. Tomorrow, um, uh, actually the 15th, right? So for me, um, that's tomorrow. Actually, for this live stream, that's today, right? Because it is the 15th. It is 2 hours, 15 minutes on the 15th. So in about 20 hours or so from now, this near Earth um, asteroid is going to make a really, really close pass of the Earth. It's not going to make this close of a pass again for like a couple hundred years. So, and they decided to look at it tonight because it's still far enough away. I think it said it was something like 600,000 miles away. Um, that's far enough away that that the apparent motion of that asteroid, um, you know, doing like a 60-second exposure with their telescopes, will produce a nice, noticeable streak, right? Um, if they were to be imaging it tomorrow at its closest approach, they wouldn't be able to see it because I mean it's just moving way too fast, way too fast. So yeah, that's that's one of the cool things about SLU, is that they can sort of use these opportunities, to not only make the observations, right, and collect the data, which is really really cool, right, really cool. Um, but they can also, I mean, as far as PR goes and advertising, that is like pure gold, right? I mean, if I mean, what what sells a system better, right, than showing a 100 200-meter wide asteroid zooming by the Earth and being able to see it, right, from the comfort of your own home, right, anywhere on planet. So yeah, it's just, I mean, what they're doing is really, really, really great. And I actually asked a question via Twitter about, and this was a question I had for them anyway, because see, my thing isn't, um, I'm not really interested in just taking pretty pictures, right? Now, there's a lot of value in those, but you know, I want I want more. I mean, being a scientist, I want more. I'm going to turn on my fan. There we go. Um, so being a scientist, I want more, right? I want to, at a minimum, right? At a minimum, I want to be able to measure the position, and I want to be able to measure the brightness, right? So I want to be able to do um, astrometry and photometry on these kinds of targets. And so, in order to do that, right, I I need calibration data, right? I need the flats, I need the darks, I need any other um, systematic um, information, so I can remove that from the raw data in order to get to the actual, I, I just want to be looking at the light from that target and from the stars around it, right? That's all I want to be able to do. Um, and so um, um, my question has been and was, for them today, is that um, in addition to the raw um, images that I get, do I also get calibration data? And you know, I'm actually looking for two separate things, right? I mean, I want all the calibration data, and I want the raw data. And their answer was is that I get calibrated data, which sort of implies that they run it run the raw data through some kind of process um, to calibrate it. And so I don't know if I have access to the actual calibration data or not. Um, but it looks like I would have access to some form of calibrated data, which as a scientist, that's exactly what I want. So it sort of looks like the implication there is is that um, not only can these telescopes produce the pretty pictures that we see, but they can also produce scientifically valid data, and um, that's what I'm after, right? So that's pretty cool. That's pretty cool. So yeah, if you didn't see that live, um, can I? I think. Let's see if I can. It's probably it's probably on my subscription list here near the top. As I said, they just did it a little while ago here. So let's see. Because I wanted to give you the link to it, the link to the. Where is it? It's here somewhere. Wow, where is it? Huh? Did I miss it? Dun, 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 dun. Well, let me. There it is. Yeah. So their YouTube channel is just. Um, I think if you do a search for Slooh, Slooh, you'll you'll get it that way. But it looks like um, the actual name of their channel is Slooh On Air Videos, and it's definitely on that. It's the latest one, um, watching asteroid 2010 WC9. So yeah, and it's pretty awesome. That's really impressive. And as I said, I'm really impressed with what Slooh is doing. Um, I'm extremely impressed with the business model. Right, you subscribe, so you can join for free, right? And have access to, they have like a forum, and if you want to look at the status of the telescopes and all that. But if you actually want to use um, the telescopes, there's a $5 a month um, um, subscription and a $25 a month subscription. And I think the $5 a month, you can take like one or two pictures, and with the 25 a month, I think it's unlimited. Um, so yeah, it's really cool. They have a solar telescope, and then they have five telescopes over at the Canary Islands, and then they have one telescope down in Chile. And yeah, I need to get a hold of them because yeah, I would uh, yeah, I'd like to get involved with them somehow. So uh, yeah, we'll see. I need to do that. I sent them a message through their website about a month ago. Never heard a thing. So I'm really tempted. They seem to be responsive to Twitter, but Twitter is really public, right? I mean, I don't want to put them on the spot or anything that way. That's a little rude, right? So I think I'll try emailing them again, um, just making them aware that I exist, and we'll see what happens there. Because yeah, I think lots of interesting things could happen. And as I said, I'm really impressed. I mean, they have a great site. It's easy to use. It works. It works. It's responsive. Um, yeah, really cool. Now, I think that I'm going to take a really quick break and uh, fill me up a mug of that newly brewed hydrogen hydroxide. So, give me like a minute, and I will be right. I'll, I'll be right back. So hold on one sec, or 1 minute, less than a minute. Much better. All right, thanks. Appreciate your patience. All right, well, cool. Well, as I said, I hope everybody's doing well today. Things are going well here. Um, I think let me thanks to Uncle Bill for finding that pretty cool nature paper um, about Europa. Did you guys see this? Um, it was, and it's kind of funny too because it was just a few days ago. Remember when we were talking about the the interplanetary spacecraft and um, how Galileo wasn't listed, right? And that greatly surprised me because it's like Galileo was a spacecraft that went to Jupiter and collected quite a bit of data, right? Well, apparently they've gone back and looked at this data coming from a couple of their instruments. Um, it looks like one of their magnetometers, right? Here, let's zoom in here a little bit. So one of the magnetometers, right? And this instrument called the plasma wave um, um, spectrometer, which just detects stuff, um, actually got some signals as Galileo was passing very near the surface of Europa. And I'm not going to get into all of this because I mean it goes way beyond what I'm able to um, talk about. But what they did is they built this model, right? And they plugged in this data. So yeah, I guess this happened. The near pass happened on the 16th of December, 1997. So 20 and a half years ago. It was like a 5 minute pass, right? Just whoosh, zoom right by, right? Um, Remain below 400 kilometers, which as you recall from yesterday, is the orbital height of the International Space Station, right? So I mean, seriously close, seriously close. Um, uh, and what they saw, let's see here. Well, here we can just get into it here. Um, so these are magnetic field strengths in the X, Y, and Z directions, right? So this black line is the actual data, right? The actual data they got. The red line is from one of their models, okay, that contained a plume of some kind of material, right? And then the green line is that same model with no plume, with no stuff. And as you can see, the model with the plume, sort of, kind of matches the actual data. So I think that's pretty cool. So this is the magnitude of the magnetic field. And you can see that the black line and the red line sort of follow the same path. So now, what this means, right, is that there's a correlation between the data um, and the model. And got to say it, right? There 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 isn't um, you know um, correlation and causation aren't the same, right, at all. But the fact that there is a correlation here, um, is a pretty strong argument for saying that maybe something was going on. So based on that, they you know they really extended themselves a little bit and created some models, right? So this is what they are thinking happened. So here's the path of the spacecraft as it passed by Europa. Um, the Hubble Space Telescope apparently observed these kinds of events at this location. And according to this data, this plume would have sort of existed here, right? So Galileo may have passed right through this plume of material. So, pretty cool. Pretty cool. So here's a view, this away, right? And then here's a view sort of from the top, right? Looking down on the plume. So pretty interesting, pretty cool. So thanks, Uncle Bill, for um, finding that. These guys really go into some really, really intricate detail in terms of how they set up their model and how they ran it and what kinds of parameters they put into it and stuff. You can see um, that there's a difference in the size of the font between this and this because I mean the only explanation I have for that is the explanation that uh, is that they had a limited budget, and as I say, every single page here costs hundreds of dollars, right? Hundreds and hundreds of dollars, and so I'm thinking this is just a conjecture, right? um, uh, um, uh, but they had to change the size of their font in order to sort of explain their model. And so that's what they did. The rest of the paper here, and as I say, this gets into like really intricate and interesting. I mean, it's actually really well written as well. So, I mean, I don't think that this is over anybody's head here. Um, Take a look at it. See if you can sort of follow this along a little bit. Um, I mean, look at this. The data that supports um, the plots within this paper is available, right? So you just have to ask for it. So how cool is that? And I mean, it's absolutely true that um, if I were to go over to PDS, which is the Planetary Data System, all of the spacecraft data, right? I mean, including telemetry data, right? Temperatures of instruments, um, uh, just all the boring stuff, right? I mean, all of it is over on PDS. So if um, um, if you're interested in seeing what this data looks like, um, do a search for planetary data system and take a look. And I I actually that's where I got my data to create my artwork uh, because it's all there, right? So very very cool. Uh, Check out the about section. Okay, yeah. I'll have to do that, Uncle Bill. Uh, yeah, I want to get a hold of these guys because they're just doing some really really cool stuff that I I mean there's I can't think of anything right now that I personally would want to use their scopes for. Um, but I'd like to get involved at a lower level, right? Um, so yeah, who knows? Who knows? I'll get a hold of them anyway. So yeah, it looks like the Galileo spacecraft might have detected um, a plume coming off of Europa, and I think that's extremely cool, extremely cool. Uh, I think one of the things that they said in the abstract was great, right? They say we show that the location, duration, and variations of the magnetic field and plasma wave measurements are consistent with the interaction of Jupiter's co-rotating plasma with Europa if a plume with characteristics inferred from Hubble images were erupting from the region of Europa's um, thermal anomalies. These results provide strong, independent evidence um, of the presence of plumes at Europa. So, this is stuff from 1997. So, yeah, very, very cool. Very, very cool. I, uh, I not having read this entire thing, I'm sort of wondering if they've looked at all the data, from other passes, because this was Europa 12, right? Which means this was the 12th encounter with Europa. Um, Now I don't know how many. Okay, so two of them came closer to the surface than 400K. Um, E12 and E26. Um, so yeah, yeah, it it'd be interesting, to look at the data from the other close approaches too, which I sort of assume that they did, but Yeah, it's very, very cool. It's very, very cool. Really interesting. Um, these are, these measurements of magnetic field strength, right, are in nanoteslas. Nanotesla. Nano is 10 to the minus ninth, right? So that's really, really, really small perturbations in the magnetic field. But yeah, they've got, looks like they've got good signal to noise here, right? So I would think that pretty much every single wiggle on here is something interesting, right? So yeah, so very, very cool. Very, very cool. All right, another swig of hydrogen hydroxide. Cheers. All right, well, cool. The let's see, should I go back to me, or should I just go on to the next thing? I posted a paper um, over on my um, okay, yeah, for the faint of heart, huh? Okay, all right. Yeah, Uncle Bill, I like to dive into things and get stuff from the horse's mouth because I find oftentimes that um, um, articles, even though well written, um, they can leave out things, they can misinterpret, um, and I mean, I look, I'll do exactly the same thing, right? I mean, I'll misinformation, I'll misinterpret things, all that, but at least I have the original paper there, and I can go over and over and over and over and over it, right, until I'm sick of it, or until I understand it. So yeah, this is a resource for sure. So the one that sort of looked interesting here that I wasn't aware of this, right? I wasn't aware of the fact that they haven't found the um, what they call the central compact object in supernova 1987A. I had no idea. I thought that was just sort of a known thing, right? So supernova 1987A uh, was, and I guess is, a supernova remnant. It's a star. It's a single star that exploded, and we saw it. It was the first supernova to be seen in the year 1987. And I actually have a story about supernova 1987A, uh, and maybe I'll um, tell you that story. Um, yeah, I thought that we ID'd it too, but I mean, this paper is entitled "The 30-Year Search for the Compact Object in Supernova 1987A." So yeah, I need to understand that a little better. But um, so here's my story, right? I um, in 1987 in um, so yeah, the supernova. I think we observed the supernova like in January of 1987 or so. Now, in 1987, in the early year and the spring of 1987, I just had graduated high school, right? and I moved um, down to Tucson in June of '87, June of 1987, and I was anxious to get down there and start at least being in the environment um, that I wanted to be in. And so classes started in August or September. I don't remember exactly when. And went to that first um, semester, basically, just taking classes, right? But, you know, getting to know the environment, um, meeting students, all of that. During that um, um, semester, I discovered that um, um, the the uh, the student club, um, um, the student astronomical club, uh, was sort of in pretty dire straits. It was not organized very well. Um, Sort of, the students who were in charge of it were just too busy to uh, you know um, devote the kind of time um, needed, right? Because I mean, basically, what we students wanted, right, was we wanted to have um, one of the professionals who was right there, right, to come and talk to us, right? We, I mean, that's awesome, right? And so we sort of formed a separate um, club, and which was controversial, uh, but we did it anyway because the original club just wasn't all that great, right? Um, so we formed a new group, and um, we were like, okay, well, we need to find some speakers, to come to our meetings. And I don't remember if it was the first one or the second one or the third one. I forget exactly, but sometime. Well, actually, I can nail it down to the actual day. I can nail it down to the actual day. I'm gonna I'm gonna do that really really quick here. Hold on. Let's see if I can. Oh, you know what? I've got a on all Unix systems. If you didn't know this already, there's a program called CAL, CAL. And if you type in CAL 1987, it will give you the entire calendar year for 1987. And so I'm looking at this. Actually, it would have been 1988. 1988. 1988. Yeah. Okay. All right. So um, we had a meeting of all the astronomy students. It was a club meeting on Tuesday, February 2nd, 1988, which just so happens to be Groundhog's Day, okay, which just so happens to be one of my favorite days of the entire year, right? Now, at the time, it sort of wasn't, but, of course, I was aware of it. Um, but the evening of February 2nd, we had a club um, meeting. And as I said, I don't remember if this was like the first one or the second one or the third one. It was one of the early ones, right? Because we sort of organized this towards the end of 1987, and then I think got it going either late 87 or early 1988. I want to say this is like the first or second one, because we would probably have monthly meetings. So February 2nd, you know, I don't think that we would have had, we might have had one on January 5th. It's like the first Tuesday of every month. That rings a bell. So we might have had one on January 5th, which might have been the first one. And we may or may not have had a speaker, don't remember exactly. But the meeting of February 2nd, 1988, we definitely had a speaker. And he came in, and uh, sort of an older guy, but very enthusiastic, very um, um, energetic, uh, very, very smart, right? I mean, like super, super smart. And he gave a presentation. I I don't have a clue what what he talked about at all. I mean, I can guess now, but I can't remember exactly what he talked about. But at the end of his talk, he said something that um, uh, it was like an atomic bomb went off. Now remember, I was riding a rocket, right? I mean, I was still riding this rocket towards astronomy, right? I mean, I was on this rocket, and I mean, it was like 50 Saturn fives, right? It's like blasting, right? So at the end of his talk, he set off this 100 megaton bomb in my head. He said, and I'm paraphrasing a little bit here, but he said, I'd especially be interested in having a couple of students work for me. And that's the only thing I really remember. So the next day, okay, 8 a.m., 8 a.m., I was in his office, right? I was in his office. Um, and I don't remember if he was there at 8 or not, but I just waited, right? I mean, that's what I would have done, right? And we met, and the conversation was really, really short. He said, why don't you come back in a week and I'll get you set up? And it's like, yes, yes, because I'd been looking for some kind of work doing astronomy, and up until then, I hadn't, right. At the time, I was working actually at a really, really, really cool position over at the library, in a section of the library called um, special collections, and that's where they keep all the special books, all the rare books, all the um, anything that's sort of deemed uh, things that you don't want anybody to check out, right? And let me, I just have to diverge a little bit on on this one. Um, they have and had um, um, at the time a vault in the back, right? And in the vault is where the really cool stuff is, right? The really cool stuff. So I held in my hand, a very, 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 very early version of um, Newton's Principia, of Galileo's work, of Copernicus's work. I held those books in my hand. It was awesome. It was awesome. Now it wasn't first edition stuff, right? I mean, it was, you know, not anything that extraordinary, but you know, quite old. You know, 17th century books from you know um, Galileo, Newton, Copernicus, all of that, and you know, I actually looked at them and you know, read the Latin, couldn't understand anything, saw all the diagrams, all of that. You know, it was very, very cool. So that was a really cool job, right? That was a really, really cool job. And when I started working as a student for this guy, um, starting on February 10th, 1988, um, I had a little about that that much sadness for not being able to keep the job at the library. I had about that that much, right? Um, but what he was doing was he was doing this thing that I'd never heard of in my life called um, speckle interferometry, and I had no idea what that was. What he did, and I think I'm going to save. I'm going to save um, speckle interferometry for another live stream. But um, what he did on February 10th, 1988, is he sat me in front of um, a video tape player and a computer that would digitize the images recorded on this video tape player, right? Now, the video tape player was recording images roughly about 30 frames per second or so. Now, the computer that was being used could digitize about 1 frame a second. And so what he had me do, right? What he sat down and had me do was run the computer such that I I would and I think there was a little bit of computer control here, but I would start the video um, player, and yeah, there was some kind of frame count, right? And so I always had to start it, you know, from the beginning, and the computer would count the frames. And when it got to a particular frame count, it would start um, digitizing. So it would grab frame 1, frame 31, frame 61, 91, blah 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 blah, and we'd run that for probably several minutes, right? Then at the end of that time, I would have to rewind the tape, right? And I would start at frame 2 and go to 32, 42, um, and do that for several minutes, right? And then, and so I would do this for all, say, 30 um, sets of data, right? And it might only be, you know, a few minutes worth of data. Maybe we ran it for, I don't know, 10 minutes or something like that. I mean, 10 minutes of data, 30 frames a second. let's see. Every good scientist, right, has a calculator within arm's reach. So let's see. 10 minutes of data is 600 seconds, and at 30 frames a second, that's 1,800 um, 1,800 um, um, images um, total, right? So that's what he had me do. Now, what do you think this data was? What do you think this data was that I was digitizing? Can you guess? It was supernova 1987A, about 3 months after it exploded. I think he went down there in like March or April of 1987. You know, they observed the supernova um, go off at the end of January, and yeah, I think it was like March or April of that year. He made a trip down to Sarah to the 4 meter telescope um, down there, and he video recorded on these um, um, special um, like high fidelity videotapes. He video recorded supernova 1987A, and um, these um, video recordings are nothing more than very, very short exposures of the object you're looking at. And that's exactly what you want to do with speckle interferometry is you want to take extremely short exposures of your target, because there's a lot of information in those short exposures. The problem with taking short exposures is that you can't really see very, very bright stars. But the cool thing is, and was at the time, is that the supernova was still very, very bright. Don't remember how bright it actually got to. I don't remember how bright it actually was at the time, but it was pretty bright. It was pretty bright. So we had, you know, literally tens of thousands of images, tens of thousands. Now, at the time, I had absolutely no idea what I was doing at all. It's all I was doing was sort of minding the tape recorder and minding the um, 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 computer, right? And the computer was actually running. I don't know what operating system it was running, but the programs themselves were written in a language that's called Forth, Fourth, and it was the first programming language um, that I'd ever seen except for BASIC, and you know, I mean, I would have done anything, right? I mean, I was on that rocket. I had just been like seriously bombed, right? So it's like whatever you want, dude, I'm gonna do it, right? And so I spent the next I want to say like 3 or 4 months. Oh yeah, that was the other interesting thing, right? When I went in on the third, the morning of the third, to talk to him, one of the first things he told me was that he was not going to have any money to pay me until the summer. And I was sort of like, so? um, Now, I mean, I had absolutely nothing at all, but it turns out, right, that I had just enough. I had just enough to, you know, pay my rent, pay my bills, feed myself barely um, until I think his funding started like in June, right? So I had to survive February, March, April, and May of 1988, a third of a year on yeah, I think it was like less than $1,000 or so. And but look, I mean, even now, I mean, not to this extent, but even now, you know, for something that I really, really want, I will practically do anything, right? I mean, yeah. So that was pretty easy. Um, Rent was cheap. I was in a little studio apartment. I think it was like it's like $150 a month, and yeah, food was cheap. Um, Single. Um, you know, uh, I had a bike, so I mean, I didn't have to um, pay for any kind of transportation or anything. So I mean, I could live really, really cheap, and it was really, really easy. But yeah, I spent those first 3 or 4 months or so sitting in front of that tape player and computer, digitizing um, data, um, um, images of supernova 1987A as it was just a few months old, right? And one of the bummers about that that first thing is that after a few months or so, he realized that he had made some kind of a mistake, and so all that data that I had um, digitized was bad. It was just digitized wrong, and so I actually had to redo all of that, and which I did happily, right? But yeah. So anyway, that is my supernova 1987A story, and I think a paper came out of that. I don't remember. Um, there was, I think there was something still wrong with the data itself. I don't remember exactly. The tape player gave me more problems than anything else mechanically, right? And the computer would occasionally, freeze up and reboot, and just the typical problems, uh, you know, that one has. But man, it was awesome. It was absolutely awesome. So yeah. Uh, anyway, so there's my 1987A story. And I guess these guys, and I know that we're past time a little bit, so I'm not going to get into this too much here, but I guess they're looking for either a black hole or a neutron star. Um, they estimated that the progenitor star was something like 14 solar masses. All right, let's get into this a little bit here. Maybe I'll expand on this a little bit more tomorrow or the next day or something. But yeah, Cal. Well, look, guys. Unix is so superior to any other um, um, operating system. It's I mean, that's extremely biased, but it is. It's just so much better than anything else. Um, anyway, so yeah, they let's see the progenitor here. Well, I'm zoomed in a little bit too much here, something like that. Anyway, they looked in every wavelength possible, right? From radio to millimeter to submillimeter to infrared to optical to ultraviolet to X-ray, right? Yeah. So progenitor mass of 14 solar masses, that would probably, at least according to all the models, right? At least according to all the theories, that should produce, probably a neutron star, right? Probably a neutron star. Um, Maybe a black hole, supposed um, um, neutron star. Don't exactly know, but bottom line, and let's just go to the end here. But yeah, um, take a look at this. They're trying to look at the geometry and they're not seeing anything at all. Um, so let's get to the end here. Oh, I always like to stop and look at the pictures if I can. Um, I love pictures. Let's see, where is there? This is a long paper too. I mean, man, these these people really put in. I mean, every paper is like this though. It's like this huge amount of effort. I mean, this stuff is not done, you know, on a lazy afternoon, right? I mean, this takes weeks and months. So here are their summary and conclusions, right? So they can't see it with Alma, um, because they're thinking, you know I think the bottom line is that what they're thinking is that it's just the object is too obscured, right? There's some kind of dust, right? Um, that does that. So by combining all, oh come on, by combining all available um, information about radiation reprocessing and geometry, the most likely remaining scenario is that the compact object is a dust obscured thermally emitting neutron star that is just too damn faint to see. But of course, look what they say. JW, JWST may save the day, right? But they're not seeing it in X-ray. They're not seeing it. They're just not seeing it at all. And I don't know. I think you would expect to maybe see it by now, right? And they're not. So yeah, don't know. It's a mystery, right? It's a mystery, and these these authors have um, looked really hard at the problem, and they don't have an answer. They don't have an answer at all, and they looked really hard, right? I mean, these guys are not messing around at all, and they couldn't figure it out at all. So they have some guesses, right? It's it's um, thermal, and it's being blocked by dust, and that's why it can't be seen. So I don't know. I don't know. Kind of strange. Kind of strange. All right. Well, I am going to stop sharing and I'm going to get out of here for today. So, hope everybody has a great evening and a great day tomorrow. Um, yeah, definitely be back for another one in a little less than 23 hours from now. So I will see you on the spin. Um, if you're new here, make sure to subscribe. Bang the thumbs up if you wish to. You can bang the thumbs down as well. Make some comments. I've got some links down in the description to my Discord server and my Twitter account and my blog. I actually, on my blog, if you go over there, you know, I hadn't done this in a long time, and I need to do this a little bit more frequently. Um, YouTube is kind enough to create a transcription of these live streams. Okay, so I can grab that transcription, and I've got a very simple Perl program that will count the number of of words spoken and count how many times I use particular words, like I and the and at and but other words too, like astronomy and moon and Jupiter and planet, any kind of astronomical term, right? It will count those occurrences too. And so if you go over to my blog, I did an analysis of my transcript from a couple days ago or so. I think it was the moon one, and yeah, I don't remember, but I think the most yeah, it was something like 7,400 words or so, um, and um, some of those words include numbers, like 100, and some other, sort of what I would call non-word words, um, but yeah, so like 7,400 words, and as far as I could tell, in that transcript, the most common astronomical word that I used in that live stream was actually the word moon. So I I did my job. So yeah, uh, you know that's an extremely nerdy thing, um, um, to be doing, but that's precisely the kind of stuff that I just love doing. So doing an analysis, um, um, like that, counting up the number of words that you say. Um, that is extremely nerdy, and extremely interesting. Extremely interesting. So I still think that there's something that I want to do with that, um, but I don't quite know what yet. And the interesting thing is, and now here's something interesting. Here's something interesting. um, I could get the transcripts from other astronomical podcasts and do the same analysis and do a comparison, right? And see, pull out the astronomical words or the scientific words, right? And and sort of see, one, what words are being used, and then two, how often are they being used, and let's see if one live stream sort of uses more astronomical terms than the others do. um, interesting interesting comparisons um, can be made. I don't know. I mean, it's totally nerdy, but could be really, really interesting. to actually see. Now, one of the things that the translator um, transcriber doesn't grab is the word and I know that I use way too much, way too much, and but it doesn't transcribe at all. So maybe there's a way to tell it to do that. I'm not exactly sure. But anyway, there's something there's something interesting in that data, and I haven't figured out exactly what I want to do with it yet. But I've got tons of it, right? I've got tons and tons and tons of it. Maybe I can turn it into art. Hmm. All right. Well, with that, I'm going to get out of here. Peace. Cheers. I'll see you on the spin. All right. Bye.